For step 2C, I'll start with the main function. I'll copy it in from the htdap template and edit from there. Here's our htdap page in our Design Recipes module. I will copy the template for the main function and paste it into my notebook. For this program, our analysis task is creating a line chart of the population over time. I'll rename the analysis function so that its name implies what it's doing. I'll call it plot population line chart. Now let's work through the rest of the HTDF recipe to finish our main function design. All of our visualization functions will have a return type of none, as I mentioned before. They show the graph or chart on the screen, but do not return anything. So the return type for main will be none too, because as you see, main returns the value that is returned from plot population line chart. I'll update the purpose so that it describes what main does, and then write some examples and tests. Working on my examples, I'm going to scroll back up to check the signature. Main takes a file name and returns none. Since main returns none, our examples are not helpful for checking that the chart the function creates is correct. But we still do want to write examples. They help us think through what input our function needs, and when we run them, they allow us to see that our function runs without errors, or maybe that errors are generated that we should fix. Now let's go back to main, and we can see already that an error will be generated. We've called a function called plot population line chart, which will serve as our analysis function in this program, which does not exist yet. So I will write the stub for that function and then run my program to check that the tests for main run without errors. In order to complete the signature, I need to think about what input type this function takes. I'm going to scroll back up to main, and I can see that I'm calling this function with the result of read, and that read returns a list of population change. So this function then should take a list of population change. As I mentioned before, all of our visualization functions, their return type is none. I'll finish my purpose and the body of the stub. Now I have a complete stub, and I hope that when I run my code, the tests will run without errors, and they do. Now our two tests for main pass, we can clearly see that we have not yet finished our line chart function design. But because the function already returns none in the stub, and main expects none, they do pass, even though we know we still need to keep working. The next step in our HTDF is to write some examples. Similarly to our main function design, this function always returns none, and therefore our examples cannot help us check that the chart that is produced is correct. However, we do still want to write them. The input type is a list of population change, so I can use these lists from above. I'll run my code and hope there's no syntax errors. The next step is thinking about the template. These visualization functions don't have a template in the same way that our other functions design have. One way that I like to design these functions is to go to a work example and copy some of the relevant code that we're going to need. So let's do that. So here's the work example for line chart. I'm going to scroll down and copy this code here, including the note template based on visualization. I'll comment out the body of the stub, and then I can start editing. So our X label, that should be the years. Our Y label is population in millions. And remember, I already thought about what I wanted this to say when I created the example, when I hand drew my example earlier in step 1C. I'll make the title BC's population, or maybe just BC population, from 1975 to 2012. Because I remember those are the years that we have the data for. For now, I'm going to comment out this axis line, and we'll talk about that in a moment. Then we need to plot our data. So I'm going to delete these variables that we have here. They're from the worked example. They don't exist in this program. And I'm going to put in a placeholder. So what I want to pass for the X value is the years, and what I want to pass to the Y value is population by years. So years needs to be a list of the years as integers. So a list containing 1975, 1976, 1977, etc., all the way to 2012. Population by years needs to be a list of the populations in millions, because that's what we want to plot, where the first entry in the list is the population for 1975, the second entry in the list is the population for 1976, etc. So the length of these two lists must be exactly the same. I'm going to comment out the set P call. That allows us to set some property to change the way that our line chart looks. So we'll look at that in more detail later. The next step is to figure out how we're going to get the years and the population by years. Our input to this function is a list of population change. Years is a field in population change, and so is population, although it's not in millions, it's in individuals. So we need to design a helper function to get all the years and to get our population by years. As those are functions that you can design on your own, I'm just going to put them into the program fully designed, and then we'll continue. Okay, I have created the three helper functions that we need. Let me scroll down to them. Get years takes the list of population change and returns a list of integers of the years. And get population in millions returns the list of populations in millions, and convert to millions as a helper that can convert a population as an integer into a float that represents that population in millions. Now we can go back to our plot function and actually update that code. So now we can create the variable years by calling getYears, and the variable population by years. Forget the name of that one, let me go check. So we wrote helper functions to extract the data that we need from our list to get it in the right format for our visualization function. Let's run this code and see what kind of graph we get. Oh, we got a name error. It says years is not defined. I must have made a typo. Oops, I did. Let's try again. Oh, and I see a typo in the title as well. I will fix that. We can see from our examples that it does appear to be creating the line chart with the title that we want. The axis doesn't look quite right because it's putting in the years as a float. But we've made some good progress. I'll fix this typo, BC population, and note that the title is appropriate for the full data set, not necessarily for our example. Now let's take a minute and think about this axis function. So I commented it out before. Now we're ready to think about it because we can see what happens by default. So by default, for the x-axis, our plotting functions will look at the data that they get and choose the axes. So choose the starting and the ending point and the way that it gets broken up along the way. We can actually control that. So maybe we want our minimum to be 1975 for the x-axis and our maximum to be 2012. We can also set our y-min and y-max. I know from writing some examples for the helper functions that our smaller data is around 2.5. I think it's appropriate to start population at 0. We could probably go up to about 6. For the data that we have, the BC population goes up to about 4.5 million. I should also show you that I had forgotten to include matplotlib. This is our plotting library. We use pyplot for matplotlib, and we do need to import that before any of these functions will work. I added that when I added in the helper functions. So let's run this again. And now we can see, I see a tiny little line on the left-hand side. Remember, we set our axes. So now our axes look appropriate, and our small examples just show up on a piece of the graph. But this looks like what I expect. So now I can call my function and call my main function with my full data set and expect it to produce the full graph. So there we go. We modified our HTDAP program so that it produced a line chart. The last thing I want to do is go back and look at the properties that we could have set for this line. So we let pyplot choose the color and the shape of the line, the thickness of the line. We can edit that if we want to. So for example, this call to set P for set properties changes the color of the line to red, makes it a little bit wider, and puts in a marker of a circle shape. Let's run this and see what it looks like now. So we can see already that there's some differences. If I rerun this cell, I can see what the full graph would look like. So the matplotlib documentation shows you many different properties that you can set. You could go back to the default one by not calling setP, or if you want to, you can play around and try to set different properties so that you can really adjust your graph or chart to look exactly how you'd like it to look.